Hi, this is Sapna Bhartiya, and we are here at Cloud in Amsterdam. And today we have with us John Morello, CTO and co-founder of Minimus. John, it's great to have you on the show.
Yeah, thanks for having me.
It's my pleasure. Now, if you look at security, I mean, SBOMs, I think few years ago, previous Biden administration, they also focused a lot on software supply chain. We started talking, even in QCon's early days, nobody was talking about security, and then security, we used to have security days, and also security does become a big topic. Software supply chain, I remember I would talk, if you walk to a booth and you talk, they have no idea what's in their container. They just spin a container, and then a lot of things can be hurling. You can just change a repository, and it was a nightmare, but things have started to get better. But with the quantum, things are, I think there is a whole phenomena going on. Gather now and harvest later, because the quantum computing is still in early phases, but data storage cheaper. So a lot of bad actors are already collecting all the data that
with the hopes to later decrypt.
Decrypt it. So the whole cryptography. I mean, a lot of things are happening in this space. So what I want to know from you before we jump into SBOM and the whole quantum is that how would you define Minimus in today's world, cloud native, agentic AI world?
Well, I mean, you asked a lot of questions there, but I want to point out like your experience and viewpoint that you had about KubeCon evolving around its security awareness. We live that very much. Our first company, Twistlock, we kind of started the whole container security space. We were at the very first KubeCon, so I've definitely seen that evolution myself over time. With Twistlock, what we tried to do was primarily help customers understand like what vulnerabilities they had, protect their containers at runtime. But with Minimus, what we're trying to do is to solve that problem before it ever happens in the first place. So what Minimus is really a library of hundreds and hundreds of pre-built, ready to run, OCI-compliant container images that we're building continuously from upstream source. Every single component in there built directly from upstream source on a distroless base. And what that means for you as a user is you can simply utilize the images from us for Python and Ruby and Nginx and MySQL and all the stuff that you use to build and run apps today. You can use our images as just drop-in replacements for the ones you already have. And by simply changing the initial image, reduce your vulnerabilities by 97+%. And so that reduces not just the risk that you have, but also the amount of work that your team has to do to maintain those environments as well.
While some may say, oh, my team can do that, but there's so much going on to keep up with that.
Yeah.
And also, you may not get that business value out of all the investment.
Exactly. Yeah. The thing is, like even if your team can do that, and having built this, I know it's very, very hard to do that.
Yeah.
But even if your team could do that, you're spending, like countless man hours on something that's a completely commoditized, non-differentiated thing. It doesn't improve, your customer or your constituents' experiences or your internal people's usage. So if you can offload that work about maintaining those commodities to us, who's built this whole pipeline to be able to do that effectively at scale and do it consistently, you can get the same end result, the same benefit, but way more efficiently, because you don't have to have, a whole team of people just packaging open source software. And I'll tell you, from having worked with, literally hundreds and hundreds of enterprises around the world over the years on cloud security, almost nobody does this really well today, unless you're a Meta or a Netflix or somebody like that, where you can just hire like the top end engineering talent and you have to run this huge platform. Your typical, bank or insurance company or, manufacturing company or whatever, this is not a skill set that they usually have. And it's not something they want to invest in because it doesn't help them improve their revenue or improve their outcomes. That's why it's such a great thing to be able to get from somebody like us, where that's our whole business is doing that really well.
I sometimes wonder, okay, we can exclude mega players like Meta or Google or whatever, but I don't even think that, but this is very specialized field, that even just by having an internal team, you can keep up with, because, I mean, as we're talking about crystograph, the thing is not just, spinning the image, because the bad actors, the especially with the AI and quantum, where we are heading, I don't that just having a full, I mean, back in those days, we used to say, just like car assembly line, if you have the visibility of your whole supply chain enough, I don't think that SBOM is enough because so many other things are happening. So you do need specialized. So can you also talk about why just say that, hey, you know what, we have the whole software bill of material, we have good visibility of it. No, that's not enough too because the cryptographic quantum is coming. So can you talk about, some people think that, right? We have the whole security team. So I think we need to hammer that point that is not enough.
Yeah, I mean, SBOM is a great capability to provide a consistent way to describe what is inside of, I mean, a container image, but it could be potentially anything. But for our discussion, a container image. So you know exactly what components and what versions are in there, which is a really useful thing. It helps you with auditing, it helps you understand your risk and so forth. But it's not sufficient to help you actually reduce the risk, right? Knowing that you have vulnerable components doesn't remove the risk of that. It just tells you that you've got the problem. So the approach that we're taking is not only do we give you an image that has no CVEs in it because of the way we build it, but we also give you that SBOM so you can prove cryptographically with just standard open source tools like Cosign and jQuery that these components, these versions, and these images have or don't have vulnerabilities. And you can know that in a very deterministic way because you don't have to guess at it. We publish that. Now, you've also asked about post-quantum, and I want to point out that's a really important new thing that's coming with SBOM now, that SBOM standard is growing to include what had been a separate thing called CBOM, or cryptographic bill of materials. So probably later this year, you'll be able to see as part of the software bill of materials, not just the components and the versions of the components that are in there, but also details about the cryptographic components that are in there, the key links, the algorithms that are supported. And that's going to make it a lot easier for customers to understand where do they stand relative to moving to post-quantum, and to be able to make sure that there's projects to get to a post-quantum future that they're actually meeting the requirements that they need to.
Can you also just explain a bit for folks who may not know what exactly it is CBOM, so they understand what it means, and what are the key element, key component that are included or need to be included in CBOMs?
Yeah. So a CBOM stands simply for cryptographic bill of materials. And conceptually, it's very similar to a software bill of materials in the sense that there was a realization in the industry that, like, hey, it's very hard to deterministically know what versions and what components exist in something if you don't have a declarative way for the creator of that artifact to tell you what that is, right? So an SBOM says, you have these versions, these components inside of this artifact. CBOM basically takes that same idea and says, okay, but you also have these cryptographic algorithms. You know, you have RSA, you've got, you know, maybe some legacy Diffie-Hellman or whatever it might be. And then you have all these new generations of post-quantum crypto that NIST is coming out with and publishing standards around now as well. The CBOM would allow you to see inside of this image, I might have libSSL, and libSSL might include these post-quantum algorithms with these particular key links. And the reason why that's valuable is now I can create a very simple interface just to use jQuery, pull that CBOM data out, and I know exactly what cryptographic frameworks are available inside of that application image. And that's something that would be really hard to do if you didn't have a clear way to describe it. We go into a lot more detail about it and have like some examples. If you look on our blog on minimus.io, you can actually see like a whole walkthrough of that. We worked with one of my longtime friends, a guy named Maruja Sapaya from NIST, who's been a real key member of creating that post-quantum work at NIST to publish this blog post that describes how it all works.
Since you mentioned NIST, what are there new frameworks, new lists are also being released to prepare for post-quantum?
Yeah, so NIST has been working on post-quantum for a number of years now, and that project, what they call the post-quantum cryptography project, has been steadily progressing over time. If you think about changing cryptographic algorithms, it's one of the most challenging software updates that you can do in the ecosystem, because it not only is something that has implementations across Linux and Windows and web servers and databases, but it also is oftentimes today actually all the way down into the silicon, right? You have ASICs that are designed to accelerate cryptographic operations. Those also have to be made capable of working with these new algorithms. So the work that Minimus does is really just to try to make sure that as those standards become available in things that are going to be packaged inside of our containers, that we're including them in there. And we've also made sure that all of our images that include cryptographic components, that we have optional FIPS versions of those images that already have CMVP validation certificates for FIPS 140-3. I think it's pretty likely that as NIST wraps up their post-quantum project, there'll probably be a new FIPS 140 variant that's going to describe what organizations should do to be compliant with post-quantum, and we'll of course support that in our FIPS images as well.
What kind of industries should care about CBOMs, or is it for every industry?
I think it's for everybody.
And how prepared organizations are at their racing towards post-quantum? The very early stage, or they're like ready, they are just looking for tools? What is the state right now?
Well, I think it's a good question. I think the answer is that most organizations today aren't really prioritizing that as a major piece of work because there's not an imminent risk that they can see in front of them. And security is all about trade-offs and timing and prioritization. If you look at how these things have evolved over time, like as the TLS standard, for example, has evolved over the years, and as we've retired legacy cryptographic formats in past evolutions of cryptography, what usually happens is NIST and the industry, people like Microsoft and Oracle and Google and AWS and so forth, they work really closely to define what the algorithms are. They build that into their products. And then the end users, like the customers that are on Azure or GCP or AWS or on Kubernetes, for example, then they're going to be able to take advantage of that. And at first, maybe it's an optional configuration, and later it's something that you can opt out of, and then later maybe it's the only way that you can do it. But that usually is the way that it works because it's such a complex, transformation to go from these legacy approaches to what the modern one is, because you don't want to have breakage, right? You don't want to create a situation where your application stops working because of that.
The thing is, I think if your data, today's data, is going to be relevant 10 years, it's already compromised because those actors have already, gathered the data and they will harvest.
That's why you can't wait, for just to say like, well, we're going to wait until there's a viable quantum computer before we start dealing with this stuff, because it takes years to develop the algorithms for it. And you're right. If somebody's recording data today that's using non-quantum resistant algorithms, whoever has recorded that data very theoretically in the future could be able to decrypt it. So that's one of the reasons why it's urgent to fix these problems before they ever, even though before there is an actual viable quantum attack that's known of.
Yeah, and you mentioned, the co-author of, SP 800-190.
Correct.
As well. Can you talk about how does CBOM fit into the, you mentioned NIST has been working on it, but the compliance framework?
One of the great things that NIST has done historically is just to provide everybody, not just the government, but industry overall, best practices and frameworks to think about how to secure different parts of their environment and how to secure different application stacks and technology stacks that they might run. So for us, like 800-190 was saying, this is the best way to think about container security. Think about it in this like layered approach from the hypervisor all the way into the application and across the life cycle of it. CBOM fits into that because a CBOM is the way that you can show that you've configured that image that you're going to ultimately have as the runnable artifact, that you've configured it from a cryptographic standpoint to align with those best practices. Because again, if you don't have that standardized way to describe what you're doing and how you're doing it, it's really difficult to know across an enterprise whether you're doing it well consistently. And CBOM and SBOM, which it builds on, is really that common framework to describe what you have and how it's configured in a way that's auditable consistently, where you can report on it and you can find the outliers and then go and fix them.
And despite the fact that however proactive a company is, of course, with regulatory industries, you can force them through compliance and things like that. Even those cases where you have seen these are the blind spots, even they can miss.
Yeah.
And that's where players like Minimus come to help them.
Yeah, and really the thing for us is we want to make it for our customers as easy and as frictionless for them as possible to just know if they get an image from us, that image is not only going to have 0 CVEs, it's going to have the most modern cryptography available. It's going to follow the best practices from NIST, from CIS about how to configure the container and also how to configure even the application within that. So in other words, we don't want to just give you images that don't have CVEs. We want to give you images that are as secure by default as possible so that when you're starting off with it, you don't have to think, how do I harden it? How do I remove legacy cryptographic implementations? I just simply know if I'm using the Minimus version of the image, it's going to be in the best possible security state by default.
What is the first step organizations should take so when they're building, post-quantum preparedness, so that they have taken at least that first step in the right direction, so that they're at least ready, So what is that first step?
I mean, I think the first step in almost any case like this is just knowing where you are today. And that's not always an easy thing to do because, again, CBOM is a relatively new standard. You probably have lots and lots of stuff that has no CBOMs published for it. But just try to get an idea, like across my environment. Okay, I'm using, Red Hat this version. I'm using Debian that version. I've got these SSL accelerators or these, this silicon that I have to think about. Getting some general idea of where you stand, and then figuring out with your vendors that you work with what their plans are for releasing, post-quantum algorithms in their products that can show you like, okay, maybe on my Red Hat environment, I know that I'm behind, but I need for Red Hat to come out with something. Whereas maybe on AWS, I can take advantage of something more immediately. So just having that first baseline, knowing where you are today, is really one of the most important first steps because it allows you to see what are the most urgent things for you to address.
And what are the things that CISOs should know about because some of these things are not just solved by the tools, right practices as well.
Yeah. Well, I mean, that's one of the key things with Minimus that we're trying to get people is to say, like, if you're the CISO, you probably are suffering today with creating enormous amounts of alerts or dealing with enormous amounts of alerts about vulnerabilities that your team is not directly responsible for, right? The DevOps team has to do that. So what we're trying to say is, look, if you can put into your process, starting with the best foundation, not just getting an image that already begins, like if you were to pull the very latest Python image today, the very latest official version of Python, you're going to get something with almost 300 vulnerabilities, 70 high and critical. You're never going to be able to have a good outcome if your foundation starts off with that. So the first step in the process is if you can start off with a better foundation, then it's much less work for you, much less risk for you, and frankly, much less hassle for your colleagues that have to deploy and update this stuff if they just simply avoid those problems to start with. And thinking about that from a process standpoint with the foundation, having a better starting point, that's a really key difference to the way that people have been doing it in the past.
I mean, CISOs, they have their toes deep into all this work, but can you also point out some of the resources that are available? It could be from Minimus or frameworks like NIST, where they can keep themselves updated, keep an eye on those resources to help them prepare.
Yeah, I mean, like, obviously, like 800/190, which we mentioned already, is kind of the gold, benchmark for how do you do container security well. So starting with that and knowing what you've got there, having some kind of good tooling, like that spans from the beginning of your development lifecycle all the way through production. There's a lot of great companies and products out there, like people are familiar with Wiz and Orca and Prisma Cloud, which is what, the Twistlock product after we sold it to Palo became. So those kinds of products that can allow you to see like, hey, maybe I've got this vulnerability in my production container environment. Well, if I should be able to trace all the way back to whatever Git repo started where that vulnerability was originally created or originally allowed to exist, that ultimately was packaged into an image that was then deployed into that container. So being able to understand, because now all software is kind of coming through that pipeline, to understand, hey, if I go fix these things upstream, instead of having to fix 1,000 different things downstream, I may be able to fix a few of them upstream and then immediately resolve all those ones downstream. And that's fundamentally the Minimus promise, is you can fix those first few things upstream, deploy our images, and now all those thousands and thousands of vulnerabilities you have in production, they just simply don't go away.
Last question, while we do agree that quantum is, I am a science fiction writer, so I've been reading about quantum for a long time, and there is a saying also that if you think that you understand quantum mechanics, you don't understand what quantum is. what we learned from OpenAI or ChatGPT. Before that, we would not even have any discussion about agentic AI 5 years before, but that company came in now. There are other players who have taken over, but they disrupted the market. Suddenly we are living different world. So, and with the AI is here, a disruption in quantum can happen any moment. So it's like if companies are thinking, oh, that's something 10, 20 years from now, that is not the right way to think about
Exactly.
it. So can we also little bit push or re-hammer the message of urgency right now so that irrespective of what, because tools are there, lists are there, recommendations are there, they should start prioritizing them, because when it's late, it's more like you have jumped from the airplane and you found that you don't have a parachute.
Yeah. Well, I mean, probably even worse than that. I mean, like, I think the thing that people don't often grasp with it is this is not about like some kind of vulnerability, like a CVE that may or may not ever be discovered. Like, you know, there's so much research that's going into quantum computing. It seems like fairly likely that there will eventually be viable quantum computers that can effectively and almost instantaneously break all of the current forms of cryptography we have. And so what that means for you is if whatever data you have that you're protecting with those, let's call legacy or at least current forms of cryptography, you know, the reason you're doing that is probably because you're trying to pass that over untrusted media, like the internet, right? Because you want to know that for sure, if I send this over the internet, somebody could intercept that. They can't do anything with it because it's encrypted. Well, if I can record all that stuff, even if today I can't do anything with it, I can keep recording it and saving it and saving it and saving it. Eventually, one day when that quantum computer exists, I can decrypt all that stuff and see all that data that I've been recording over those years. And that's really the risk. And that's why it's not something you can just wait until that happens, because really everything that somebody is able to intercept today is potentially able to be compromised in the future.
John, thank you so much for diving deep into this topic. This is really important topic at this point, post-quantum. Of course, the whole AI thing is, so thank you so much for re-hammering those messages. But this is also a space which is like growing fast. So I would love to, talk with you folks again.
Absolutely. Be happy to do so.
Yeah, but I really appreciate your time with this. Thank you.
All right, man. Thanks for having us. Appreciate it.